Good morning, good afternoon, and good evening to wherever you are in the world. Today I would like to teach you how to find the zeros of the given function as well as the multiplicity of each of those zeros. So here we have a function x raised to the 6th power minus x raised to the 5th power minus 2x raised to the 4th power. The first thing is to find the zeros we have to factor, all right? And we have to factor out common terms that we have in each one of these three terms. So I notice that I have x to the 4th is the highest common factor, right, in each of these three terms. So that's what I'm going to pull out, all right? That's what I'm going to pull out. I'm going to pull out an x to the 4th. Now what's left then is basically what you're going to think about. You're going to divide this term by x to the 4th, and you know you just subtract those exponents, so you're left with then x squared. Minus now, you're going to divide this term by x to the 4th, and you realize when you subtract those exponents, you're just left with x to the 1st power or just x. And then you're going to divide this term by x to the 4th power, and you realize that they just cancel, and 4 minus 4 is 0, and anything raised to the 0 is just 1. And therefore, it's going to be a 2 that's left over, so minus 2. All right? Now, from here, I realize that I have one factor here, okay? And I'm going to kind of put this in a parenthesis. I'm going to show you, I'm going to expand on this in a second, all right, to kind of show you some of the similarities here amongst the factors. But what I realize here is that this isn't really fully factored, right? You kind of recognizing this, you're like, oh, is that a quadratic? And yes, it is indeed a quadratic. What we can do is we can now factor this on out. So remember, you're thinking about two numbers that might multiply to -2, but that add to -1. What do you think they are? Right, exactly. Did you say x minus then? So a -2 and then a +1? That'd be correct. Now, what you can also do is you can check yourself here. If you weren't sure, you can use this program that I have a video for, by the way. Check out the link in the description below. You can run this program in your calculator. You can plug in your a, b, and c values of your quadratic. Remember, a is the coefficient of the x squared, which is just 1, so type in a 1. Your b value is going to be -1, okay, because that's technically the coefficient of the x value, so type in -1. And then go to c value, and that's going to be a -2, okay, and you hit -2 and hit enter. Now the values here, you might say, whoa, wait a minute, you said -2 and +1, what the heck's going on? These are the solved x values. This is what x will equal eventually, okay? These are the zero values, all right? So what you can do actually to find the factors then, you could use your calculator, program it the way I mentioned in the video, link in the description below, and then just invert the signs here, all right? And then you can get back to your factors basically. But what we got going on now is the function's value is going to equal x raised to the 4th, okay, multiplied by now this whole thing. Now, it looks like I got nice binomials here, and that's all fine and dandy, but this doesn't look like a binomial. But guess what? I can make it look like a binomial because I could just say x plus 0, right, raised to the 4th power. Now this is going to look very, I don't know, consistent, so to speak, right? We have basically three zeros. We're going to have a 0 now at 0 for x. We're going to have a 0 at not -2, but +2. And then we're going to have a 0 at x is equal to -1. And the reason why that's the case, remember the whole idea about the zeros, is we got to think about what x values produce an overall value of 0. So if you just think about this, imagine x were 2 and you subtract 2 from it, this whole thing would be 0. I could care less what's in here, although that would be 2. I could care less what's in here, although that will be 3. And when you take 2 times 0 times 3, guess what? The whole thing's 0. All right, that's the whole idea. And to easily see that, it's best to do it in factored form. If you want a whole bunch more practice on this, I got 20 or so videos out there just on like finding the x-intercepts, okay? That's basically synonymous with find the zeros. If you're like, find the zeros, that's confusing language, just turn that into find the x-intercepts. If you're like, oh, I know how to do that, well, that's how you'll always interpret the problems then. Sometimes terminology, well, almost all the time terminology is important, but sometimes certain terminology doesn't really work well. Like I don't really like this find the zeros because it's confusing to me. It's like zeros, should it equal 0? Or what equals 0? Technically the y value will equal 0, the function's value equals 0, and what this is basically saying is find the x values where the function's value is 0, okay? In other words, that's the x-intercept. But, not to belabor the point a little bit, we now have our factors and we can find our zeros. So what we're going to do is we're going to take each of these now terms, and you don't even have to use the exponent here, okay? You can just take whatever inside the parentheses now and set those all equal to 0. So obviously x plus 0 equaling 0. Obviously you already know that x is going to be equal to 0, right? I mean, that's pretty straightforward. Then you got the next one where it's x minus 2 is equal to 0. All you got to do is add the 2 on over to both sides, and you're going to say x is equal to positive 2. Oh, and that's what the calculator told us, right? That's what it told us up there. And then the last but not least is going to be x plus 1 is equal to 0 minus 1 for both sides. And look, la-di-da. -1, that's what the calculator told us it was going to be. So the calculator solves the x values, not the factors. All right. Now we basically have these zeros, and that's all fine and dandy. Now I have to give the multiplicity of each of these zeros. So how do I do that? That's very simple at this point. All you want to do is you want to find the power of each individual factor, right? Or each individual zero, I should say. So when I solve for x is equal to 0, remember, I solved it from this factor, so to speak, right? And what was the power of this factor? Well, it was 4. And guess what, ladies and gentlemen? That is the multiplicity then of this 0. It's very, very easy now. The multiplicity now is going to be equal to 4. Then when I solved this thing, when I said x was equal to 2 down here, right? Where did that come from? Well, that came from this factor. What was the power of that factor? Well, it was a 1, okay? So guess what? The multiplicity of the multiplicity of then the 0 at x is equal to 2 will be also 1. I don't know why I wrote 2. Well, because I said 2, I know why I did it, but I shouldn't have done that. And then similarly, to find that 0 value of -1, I know that's confusing, right? But this is the x-intercept, right? That's the x value of the x-intercept at one location of the function. And what I realized then is that the exponent here of that factor that gave that 0 was 1. So therefore the multiplicity will be equal to 1 as well. Now what you can do to gain a little bit of understanding, you can graph this thing, right? So go to x raised to the 6th, x raised to the 6th power, then subtract x raised to the 5th, and then subtract on out 2x raised to the 4th, all right? Go to zoom, hit standard, number 6, I hit 3, that should be good enough anyway. It should give you the same output. Actually, you know what? I'm going to zoom in. I'm going to go to zoom, go to hit 2, hit enter, and there we go. Now, let's take a look at what this is showing us. So this is now, remember, graphs are just visual representations of what this function is, or meaning the corresponding x values that will give corresponding output values of y. So what I realize is that this thing crosses the x-axis or touches the x-axis in 3 places. One place here, one place here, and then one place here, okay? Whenever you get the function actually crossing the x-axis, okay, it crosses it, you'll always know it's going to be odd. Whenever it just touches the x-axis, it looks like it's just coming up, touching, and then bouncing back down. When you get a little bounce, okay, or when you get a little touch and go, so to speak, you can think about it that way, it's always going to be even, all right? And here it crosses, so that must be odd. Let's see if this now correlates. So this was a value of -1, okay, the 0 at -1, the x-intercept of -1. Look, we said the multiplicity should also be 1, and that was odd. Okay, great. Then we said at 0, we said the multiplicity should be even because it's a bounce, it's a touch and go, okay, and the multiplicity at 0 was equal to 4. Oh, look, it's a bounce, it's a touch and go, okay? And then at x is equal to 2 over here, right, we said that it should be odd, and look, it is odd, it's equal to 1. Now, if you want to understand why certain multiplicities give certain behaviors, well, guess what? I got a video on that. Check out the link in the description below. All right, if you're curious, I highly suggest you take a look at it. But yeah, that's all there is to it. So hopefully that makes sense. I really appreciate you guys tuning in, and I want to help you with more problems. All right, check out our channel, by the way, because we got thousands, not only in math, but physics, chemistry, and we got a whole lot of other stuff coming. Thanks so much for supporting us. It means the world to us. It really does. And we love producing content for you, so I hope it kind of shows. And we usually go into a lot of depth. So if you really want to understand like how to do something, or if you really want to learn how to do it, I highly recommend, I mean, maybe I'm a little biased, but I highly recommend our channel because that's what we focus on. We don't just give you like, hey, this is what you do and be done with it. And we try to teach you why it's happening. Anyway, thank you so very much. I'll see you soon. Take care.